Good evening all and welcome to the class. Apologies, we are starting late. This is due to the fact that 8 o'clock clashed with my evening prayer time, but I just finished my prayer, so you are all welcome to the class. This is our week 3, and as you are aware, in the first week, I released the slides introducing you to epidemiology. Last week, we had lectures where we discuss descriptive epidemiology and analytical epidemiology. So this week, we are going to have a look at theory of disease causation. That is to say, what are the theories behind how people are infected with diseases? Because you need to know the mechanism of infection before you can put in effective control measures. Whatever we are doing in epidemiology is simple. We are trying to build sufficient data and knowledge for effective disease control. So one of the principles cardinal of public health, as I have said, is epidemiology. And one of the fundamental assumptions of epidemiology is that diseases do not occur in a vacuum. That is, they affect a host. That is, they affect human. Now, if diseases affect human, how do they affect the human? What are the factors? What are the reasons? What are the parameters that warrant a particular disease to affect Mr. A and Mr. B and leave Mr. C alone? We saw it in our previous lectures, how some diseases affect children only, some diseases are for the elderly, some diseases are for middle age, and things like that. Now, how do diseases even occur? What are the theories? These are the theories how diseases are formed. Now, that is what we are going to discuss in this our class. And we are going to start by discussing what are the basic disease theories. Now, permit me to start the slideshow. Now, models of disease causation. Now, going by the assumption that diseases doesn't occur in a vacuum, so it must affect a person and it must be caused by something. There is no way you will sit down and say, oh, I am diseased, I have certain illness. And then you say there is no causation. Definitely, there has to be something that caused the disease. Therefore, there are theories on how diseases are formed. One is the epidemiological triangle. Epidemiological triangle is a model, a theory, which we'll discuss. Then there's the pie chart model. Pie chart is also a model of disease theory causation. Now, the fundamental assumption is that diseases do not occur in a vacuum. They affect people, one person or the other. And there are certain factors that warrant diseases to affect Mr. A and leave Mr. B alone, and affect Mr. C and leave Mr. D alone. Now, all those are what we are going to discuss. Now, the epidemiology triangle is used to analyze the role of interrelatedness of each of the 3 factors in infection. Those factors are environmental factors, the host factor, and the disease-causing agent. That is the agent of the disease. Now, let's discuss the host. The 3 basic cardinal of the triangle are host, environment, and the agent. First, there has to be an agent that causes the disease. Secondly, there has to be a host that is being infected by the disease. Thirdly, there has to be a suitable environment for the transmission of the disease. If you have the disease-causing agent and the host is not available, then there won't be any disease. If you have a disease-causing agent, And the environmental factors
What do you want?
for the transmission of the disease
I
are not.
She's not around.
Chukunonso, can you please mute yourself? Now, the host usually refer to human who can become infected. And in the host itself, there are certain factors, that is in intrinsic factors inside the body of the host, like the immunity, like the genetic disposition of the person. And then there are extrinsic, that is outside factors, those factors that are not inside the body of the host, such as behavior, eating behavior, personal traits and activities. Those are external. Internal traits are genetic factors and the level of immunity. If you take two people and expose them to the same disease-causing organisms, one of them may fall sick, the other one may not, because of the difference in genetic composition of those people. A typical example is malaria with those that are having the sickle cell. Because of their nature of the cells, the parasite couldn't infect. So you find that they don't usually have malarial attack. Another is once you expose people to, say, smoking or asbestos, those that have genes for the causation of cancer in their body will develop lung cancer. Those without the genetic disposition may not have the lung cancer. So genetic disposition and the strength of the immunity, the level of the immunity of the individual will determine whether the host is going to be infected or the host is not going to be infected. Then you have personal traits like gender, sexual activities, socioeconomic status. Then you have behavior, including feeding habit, exercise, smoking, drinking. Now, if you expose the same people, 3 people, to a particular disease-causing organism in a particular environment, you find that one will fall sick, the other 2 may not fall sick. What could be the reason? Probably because he falls sick because he's an alcoholic, and that taking of alcohol predisposes him to that particular diseases. Why will somebody fall sick again? Probably because of his feeding habit. He usually eats a lot and he's obese, he's overweight. So if you expose them to environmental factors that may cause certain diseases, you find that he will fall sick. Some other people, because of their sexual activities, if you expose them to environmental factors and certain disease-causing organisms, some may not fall sick because they do not have the sexual activity that will expose them to having the sexually transmitted diseases. Now, genetic disposition, I have already discussed that. Immunological factor, the strength of the immunity and level of previous exposure. Now, if I tell you that a disease will affect a host, that is a human being, these are the factors that you should think that will influence whether one will get infected with a disease or the person will not get infected. Because once these factors changes, the predisposing, the probability of having certain infection will also change. If your immune system is very strong and the 2 of you are exposed to the same level of virus or bacteria or parasite, then the person with weak immunity will end up being diseased. Whereas the person with strong immunity, the immune system will fight the disease. So once we say host, that is human, that can that can have a particular disease, remember these factors that can influence whether the human can have the disease or the human will not have the disease, particularly personal traits, exercising, not exercising, feeding habits, and things like that. Now, let's look at the agents. Now, what are these agents that causes diseases? They are almost everywhere in our environment. An agent is an external organism that causes particular diseases, and the agent must be present before disease will be formed. If you take, for instance, Plasmodium parasite as the agent causing malaria. If you go to a particular community or a country where they do not have that particular parasite, that means the agent is not there. So there won't be infection, there won't be malaria. If you take the bacteria causing tuberculosis, if the bacteria is not available or is not present in a particular community because of their environmental factors, maybe they are temperate region, maybe in Antarctica or somewhere. So due to the lack of the agent, then there won't be disease. So an agent must be present. Agent could be three different types. Agent could be biological. Biological means living organisms that causes diseases such as bacteria, virus, fungi, parasite, or even higher animals like snakes, sharks, bears, and other animals that kills or injure human. Those can as well be considered as agents. And when we talk of agent, we say agent could be either biological, physical, or chemical. Now, when we say an agent is physical, that is a non-living agent. It could be radiation, it could be intense sunlight, it could be storm, that is these cyclones, it could be repetitive mechanical force that can cause injury to either your ears or to your body or to any part of the body. Now, sorry, let me go back to previous. So an agent could as well be chemical. That is when you are exposed to certain chemicals, certain hazardous chemical, you can fall sick. If you are not exposed to an agent that is a living organism, either bacteria, virus, fungi, parasite, or any higher animal that can cause injury or sickness, and you are not exposed to physical agents such as radiation, intense sunlight, storms, or repetitive mechanical force, and you are not exposed to any chemical, then you cannot be diseased. You won't have any infection. There has to be an agent that will destabilize your system and make you fall sick. In the absence of an agent of any type, certainly hospitals must close. Take, for instance, if tomorrow we'll wake up in the entire world, all biological agents like bacteria, the harmful one, the virus, the fungi, the parasite, will all disappear and there are no snakes, no radiation, no exposure to chemicals, people will start throwing parties and hospitals will close. And by the time hospital close, most of you will lose your jobs because you are there as in the hospital waiting for people to fall sick. And I know you will not pray for when we'll have a sick-free society. Now, the environment. This refers to the extrinsic factors that affect the agent and create the opportunity for exposure. Now, environmental factors could be climate, biological factors, socioeconomic factors such as crowding, type of residence, vegetation, rivers, ponds, sanitation, and the availability of health service. Let's take these environmental factors one by one. Physical factors such as climate. Do they cause diseases, physical factors like climate? Yes, they do. They cause flood. And once there is flood, there could be accidents, there could be building collapse, and then it will now lead to certain diseases. There would be shortage of clean drinking water. Biological factors such as insects. These are one of the most important environmental factors. If you, for instance, take mosquito in itself alone, is responsible for transmission of malaria, which in turn is responsible for killing about 5 million children under 5 annually. This tragedy is because there is an agent. That agent is the Plasmodium parasite. This tragedy is because there is a host, that is human. And this tragedy is because the environment is conducive for the insect to lay eggs, hatch the eggs, breed, and then go into people's room and then bite them and then transmit malaria. Now, take for instance, a situation whereby the environmental factors are unsuitable for the insect, for mosquitoes. For instance, in Canada, where mostly the temperatures are sub-zero. Of course, mosquitoes will not even go there. If they make mistake of going into any plane that is going to Canada, as soon as the plane lands, they come out, they die. Even if they lay eggs, the eggs will be frozen. The larva will be frozen. So since the factors, the environmental factors, are not suitable for such insects to serve as vectors, that disease will not be in that particular area. It will not affect people in that area. Another disease that is being transmitted by insect is trypanosomiasis, that's sleeping sickness. You have a lot of them. You have onchocerciasis, that is river blindness. You have so many other diseases. And these insects are mostly found in the tropical environment. Tropical, starting from the rainforest in Brazil, coming down to Africa and passing through India. You find that the environment is suitable for the insect to live and reproduce. Therefore, they are now transmitting parasite in those areas. If you go to areas where it is completely barren, desert, you will not find CSA fly. In the absence of CSA fly, you will not find sleeping sickness. In desert areas where there are no rivers, you will not find the fly that is responsible for transmission of river blindness. That is the Simolium damnosum species. So the environment has to be conducive. Vegetation, rivers, pond, and sanitation. Where there is no proper sanitation, you have a lot of bacteria. Once rainwater comes and washes the non-proper sanitation, people that are defecating outside, it goes into the river, into the well, and then people will drink it, and then they will fall sick. Now, if the environmental factors are suitable, and then there is an agent, and there is a host, certainly there will be diseases. If you look at the triangle, if there is no host, there will not be any disease. The environment and the agent will just live and die without going into any. And if the host is there and the environment is suitable and there is no agent, of course there won't be disease. For instance, where there are human beings as host and the environment is suitable for mosquitoes and there are mosquitoes, if there are no Plasmodium parasites, then certainly there won't be malaria. So always the three have to coexist and form of a triangle. If you remove one leg of the triangle, the other two will collapse. So triangle, the disease theory, the triangular disease theory is that there has to be a host, there has to be agent, and there has to be an environment. Now, if there is a host, as I have said, and there is an agent, and the environment is not conducive, there will not be diseases. If there is environment, an agent, and there are no hosts, there won't be any disease. So there has to be the three together, host, agent, and environment, before there will be any disease. Now, this theory is simply showing you, as a public health practitioner, whenever they come and tell you there is an outbreak of disease A, what you should do, simply sit down and draw a triangle. Who is the host? They will tell you it's mostly affecting women. Of what age range? Women of reproductive age. Fine. What is the agent? We don't know. You now go and collect blood samples, urine sample, fecal material, or whatever. You try to find out the agent. You now try to find out, when does it affect people? Is it in the rainy season? Is it in the dry season? What are the environmental conditions that is suitable for this agent to affect the host, the women that have been affected? Once you finish that study, then you can quickly call for a meeting and say, look, this is the agent, these are the environmental factors, and these are the people that it affects. How do we break the transmission? A simple change in environmental condition will now make the agent unsuitable to affect the host. For instance, where there is sanitation, where there is no stagnant water body, where there are no vegetation for mosquitoes to thrive, even if there is host and the agent, even if there are human on children under 5 and there is plasmodium, if the environment is not conducive and there is no mosquito, there won't be malaria. So always try to study the disease, the agent, and the environment, and then bring solution. How do you change the environmental factors to make it unsuitable for the agent? And in some cases, in those days in Africa, when they cannot control the environment and the agent, the host run away. A typical example is people migrating away from where there is vegetation and SSA fly and trypanosome parasites. They could not control the SSA fly. That's the environment. They cannot eradicate the agent by treating and killing the parasite in the human body or in the animal body. What happened? People migrated. They left central part of Africa sparsely populated and went to areas where there are no SSA fly. So in some cases, you either remove the host or put a barrier between the host and the environment. A typical barrier is mosquito net. Mosquito is part of this environment and is responsible for coming to your left to pick this agent and go up and deposit it on the host. So let the mosquito be there. Let it now come and pick, let it go down the triangle to the agent, pick the agent. By the time it is flying to go and meet the host, let there be a mosquito net. That means there won't be transmission. Now, at any particular time, frequency of disease and injuries is influenced by the balance between the three. Once any of the leg of the triangle is broken or tilted, the balance will change. With change in the host or environment or the disease-causing agent itself, presence and intensity of diseases also changes. Take, for instance, if you go to a particular environment, you discover that a lot of people are having malaria. The first thing you do, give them mosquito net. That means you have a barrier between the environment, that is the mosquito, and the host. Quickly, you will start noticing the rate at which people have malaria will start declining. Go into the environment, clean the drainages, fumigate the area to kill the mosquitoes. You have changed the environment, so the level of disease will change. Allow the environment to deteriorate. People should be defecating outside. Water should come and wash the fecal material. Lack of proper sanitation. Diseases keep increasing. Daily, you find people complaining of one disease or the other as a result of a change in the environment. Now, there are changes in environment that cannot be controlled easily. That means in such situation, people will either migrate or temporary evacuation. A situation whereby a cyclone or a heavy rainstorm is coming, there is no way you can say, oh no, how do we do this? Do we put now? Quickly give an order for people to evacuate. Let them all run away. I hope you know that running away from danger is the best form of defense. Don't think that, yes, you are human, you are brave, you are going to fight. No. If you are holding the hand of your girlfriend or your wife and you are walking down the street and somebody come and give you a dirty slap, you see him very hectic, remove your shoe, give it to your wife, tell her to bring it home. Start running. Run down the street, take a sharp bend so that he doesn't catch you. Go home. By the time she comes, tell her, Kai, this place is still paining me. Please help me with some hot water. But if you say, no, you are going to stay and be brave, my friend, forget it. He will break your bones and then you won't live to tell her the story. Just give her your shoes. Even if she's your girlfriend, pick your shoes, give it to her. I beg, honey, carry this shoe, come home. You run. Running away from danger is the best form of defense. So even in diseases where you cannot control the disease, evacuate. Let people run away. This is a typical diagram. You can see we have the human body, which is depicted in the diagram. That's the host. You can see the agent all over. You can see bacteria, you can see fungi, you can see viruses, and all those ones now are the respective agents that are responsible for causing the disease. Now, the black background is the suitable environment. If the environment is not suitable, therefore, all these bacteria, fungi, and others will die because the environment is not suitable. And when they die, they cannot infect this human body. But a situation whereby there is a host human, the environment, the black background is conducive, and there are agents, then certainly there will be diseases. So that is the epidemiological triangle. Now, the pie theory. The epidemiological triangle doesn't work in all diseases. What I'm trying to say, sorry, I've been facing some challenges for electricity, so I will just try to quickly finish. I'm using my phone too. The triangle model doesn't work well in some diseases, particularly the non-infectious diseases. For instance, if you look at lung cancer, if you look at accidents, that's fractures. If you look at certain type of cancer, the ovarian cancer and things like that, there is no epidemiological triangle that will explain that. Why? Because there is a host, but there is no any agent, particular agent that is responsible. It's a physiological disease. If you take accidents, yes, there are agents, there are causes, but then there are no environmental factors that are influencing the causes. So in non-infectious diseases, for instance, lung cancer, there are certain things that will influence whether someone will get lung cancer or not. It's not the environment and the host and the agent. Let's look at it. One, genetic disposition. Genetic disposition means if you have genes that are prone to being cancerous, you inherit genes that will mutate and change your cells and make your cells cancerous, or exposure to certain materials such as asbestos, or exposure to environmental pollution, particularly air pollution of either vehicles, gases, and other industrial gases, and then habit and lifestyles such as smoking cigarettes. Now, in a situation whereby you have these factors, you cannot sit down and say it's an epidemiological triangle that you are going to use to identify what are the causes and how will you control the disease. Now, you have to use what is called a pie model, causal pie. Causal pie, simply take a pie chart, divide the pie chart into 3 or 4. Put genetic disposition to cancer as number 1. Put exposure to certain materials such as asbestos as number 2. Put exposure to environmental pollution as number 3. Put habit and lifestyle such as smoking cigarette as number 4. Now, when all these 4 forms together, they form a complete cycle, a complete 360, and then cancer is formed. If you remove one, you can replace it with another one. For instance, exposure to certain materials such as asbestos, you can say, okay, remove asbestos, put any other material that causes cancer. It can still cause cancer. Let's further look at certain examples of how the pie chart is. Now, an individual factor that contributes to the cause of the disease is a piece of the pie. Take a piece of paper, divide it into a circular piece of paper, divide it into 4, or take an orange, cut the orange into 4, open it up. When you close it, it forms a complete orange. Now that is disease. When you open it, each individual of the 4 units, 25% will go side by side. Take the first 25% as exposure to asbestos, the other one smoking, the other one predisposing genes to cancer, the other one environmental factors like air pollution. Put them together, you put cancer, you call that complete orange cancer disease. Open them up, each individual is a factor. So you can cut one of the orange pie, bring another reason, and it will still form cancer. Now, after the pieces of the pie fall into place, the pie is complete, and then disease will occur. Disease will not occur if the factors are not complete. And the individual factors are called component factors. For instance, if you cut the orange into 4, each of the 25% of the orange, when you open it up like this, is a component. And each component, when you form and close them, they form the complete orange. Take one watermelon, slice it into 7. Each part of the 7 sliced watermelon, when you put them back, they form the watermelon. And then each slice now is a reason for causing, say, road accident. By the time you put them together, you have road accident. Take another watermelon, slice it into 3, open it up, and imagine that they are the cause of HIV. 1, exposure to virus. 1, indiscriminate sexual activities. 1, blood transfusion. Put them together, they form the watermelon, which is HIV infection. Remove them open, they are individual causes that forms reasons why someone should have HIV. The complete pie, which may not be considered as causal pie, is sufficient cause. A disease may have more than one sufficient cause. We are going to discuss that. And a component that appears in every pie or pathway is called a necessary cause, because it is necessary for the disease to occur. I will explain this necessary cause in due course. Take, for instance, a causal pie model suggests that a pie is 360. Each pie consists of sufficient cause. The percentage of each is not equal. Take, for instance, HIV. If you slice an orange into 4, 1 is exposure to some HIV. 2 is lack of antiretroviral. 3, unprotected sexual activity. 4, blood transfusion. If you merge all the 4, they form HIV infection. But out of these 4, there is 1. If you remove it, there will not be HIV infection. Think of that one. Don't mention it. Just think of it. 1, exposure to the virus. That is to someone with HIV. Lack of antiretroviral. Unprotected sexual activity. Exchange of blood or blood transfusion, or using the same syringe or using the same clipper. Out of these 4, there is 1. If you remove it, there will not be HIV transmission. And you know what that one is? It's exposure to someone with HIV. If there is no exposure, lack of antiretroviral doesn't matter. Unprotected sexual activity doesn't matter. Transfusion of blood doesn't matter, because the blood that is being transfused into your body is not from someone that has HIV. Unprotected sexual activity, the person you are having risky sexual activity with is not someone with HIV. Using the same clipper or using the same syringe, the person you are using the same syringe with is not a person that has HIV. So it means without exposure to someone with HIV, whatever are the causes, the other 4 causes, you are not going to get HIV. Now, exposure to someone with HIV is a necessary cause. If you remove it, the whole pie will not lead to disease. However, these 2, if you remove using the same syringe or blood transfusion, these 3 can still cause HIV. Okay, remove unprotected sexual activity. Put blood transfusion. Exposure to someone with HIV, lack of antiretroviral, blood transfusion will cause HIV. You see, unprotected sexual activity is not necessary. However, it is one of the causes, but it's not necessary cause. Exposure to someone with HIV is a necessary cause. So that is the difference between a necessary cause and any other cause that is not necessary. Look at it now. Exposure to person with HIV, red, is necessary. Absence of antiretroviral, engaging in risky sexual behaviors. You can remove the green pie and put what? Blood transfusion. Still there will be HIV. You can remove absence of antiretroviral and then put blood transfusion engaging in risky sexual behavior, exposure to person with HIV will lead to HIV. Now, this red is a necessary factor. Without it, there will not be HIV transmission. Now, the complete pie like this, the whole 360 is a causal pie. Sufficient cause for you, for a person to have HIV. Now, we are not talking of triangle again. We are not talking of environment, host, and agent. We are talking of factors. As a public health practitioner, if you are to remove one factor to stop the spread of HIV, which one are you going to remove? Exposure to person with HIV. Always look at the necessary factor in a disease. What is it that is compulsory before this disease will occur? Once you identify that thing, remove it. Once you remove it, whatever the factors are, there won't be. Make sure people with HIV are not being engaged in risky sexual behavior, are not the ones donating blood. As soon as you do that, forget about it. People can go in and start throwing parties. There won't be any more HIV. So in the other one, I said if you want to control a disease that is being transmitted through the triangle, look for a barrier. How do you stop the agent from reaching the host? How do you stop the host from interacting with the environment? How do you stop the environment from being suitable for the agent? But in a pie model, there are causes of disease. Each is like a pie in a pie chart. And there is what is called a necessary cause. Remove the necessary cause, no disease. Now, let's look at this thing. Now, you can unmute yourself. I will start asking you questions in the next diagram. For death as a result of car accident, how many factors do you think can be the causal factors? See, I have asked you to unmute yourself to contribute to the class, not to unmute yourself and okay, remain muted, please. Since you cannot control yourself as adults, unmute yourself where you don't have, if you have your children, or you are watching TV, or you are holding a radio, or your friends are there, do not unmute. If you unmute and make unnecessary noise, I will have no option than to close the entire class. Unmute yourself if you are not watching TV, if your children are not with you, if no noise in your surrounding. Only 3 or 4 people should unmute. Let's answer these questions.
Dangerous drive.
Now, for death as a result of car accident, how many factors do you think can be causal factors? 1, bad road.
Drunk drivers.
Drunk drivers.
Overspeeding.
Overspeeding.
Reckless driving.
Reckless driving.
Dangerous drive.
Failure.
Using forward
Sleeping on
driving.
steering.
Using
Steering.
forward,
Sleeping on steering.
Basically
on
everything
steering.
on the list.
Brake abuse.
Sleeping on steering.
All of them.
Okay.
All of
Okay.
them, sir.
All of the above.
Now,
Basically all of them on the list.
all of them can cause what?
Car accident.
Can cause car
Car
accident.
accident. So if I ask you now to draw a causal phi for car accident, all you need to do is you take 3 or 4.
Okay.
Now, let me change the question. For death as a result of head-on collision, car hitting car, how many of these factors can be responsible? All of them, isn't it?
Overspeeding.
All of them, Prof.
But is there a necessary factor here?
Oh.
If it is car accident, car hitting car?
Brake failure.
Yes, sir.
Overspeeding.
The driver.
The
driver.
Okay.
Overspeeding,
Okay,
reckless
now let me bail you out. All these ones could be factors for death as a result of car accident, but there is no necessary factor in them, because any combination can cause car accident, isn't it?
Yes,
Yes.
sir.
Any combination can cause car accident. Now let's look at this one. Now this is a pie death from a head-on car collision. Head-on car collision, meaning a car coming to hit another car head-on. Who is making noise, please? You see, I will have no option than to mute you all, because I thought we are all responsible in this class. Why should somebody unmute himself and be talking to his friends? Now, if you look at this one, death from car head-on collision. This one is not accident. Head-on collision, meaning coming head to head, isn't it? A, car hits another vehicle. B, poor road design. C, high speed. D, slippery road. E, tired drivers. F, low visibility. G, poor light. H, faulty brakes. I, inexperienced driver. J, unrestrained drivers. Now, from B to J, they are all component causes. But A, car hit another vehicle, is a necessary what? Factor.
Necessary factor.
Because if you have poor road design, you have high speed, you have slippery road, you have tired driver, you have low visibility. If a car didn't hit another car, there will not be death from car head-on collision. Are you getting this example?
Yes, sir.
So
Yes,
for death from car head-on collision, if you look at the pie charts, if you look at number 1, A is there, B, F, G, and H. Because B, F, G, and H are all component factors.
component factors.
But A, where a car will hit another car, is necessary.
Necessary.
Without it, there will not be what? Death.
Accident.
There will be no
There will
death.
be accident. So if you look at pie number 2, is A, C, F, I, and J. If you look at pie number 3, is A, C, B, D, and E. Now, in each of these pie, let's come back to pie number 1. If you remove A and replace it with C, that is, there will be high speed, poor road design, F is low visibility, G is poor light, H is faulty brakes. Will there be death from car head-on collision?
No, sir.
No,
No,
sir.
because car didn't hit another car.
Car.
So always when you are talking of a particular disease, think of the necessary factor. In HIV, if there is no exposure to HIV virus, there won't be HIV transmission. In COVID-19 coronavirus infection, if there is overcrowding, there is no distancing, there is no washing of hands, there is sharing of spoon, sharing of anything, in as much as there is no contact with the virus, there will not be transmission of coronavirus. So coming to contact with the virus is a necessary factor. So as a health professional, when a disease is caused, you are using the pie model theory, always look at what are the factors that causes the disease. Draw them in a pie chart. Which factor is necessary that once you remove it, the entire disease will collapse? That factor is called necessary factor. Remove the factor, you are done with that particular Now, let's look at this chart. Lung cancer. Lung cancer could be as a result of genetic predisposition, that's the yellow space. It could be exposure to asbestos. It could be living in the city. And then that green one is smoking. Now, which one is a necessary factor here?
Smoking, sir.
Smoking.
No.
Genetic
predisposition. No.
Genetic predisposition.
No.
City living. No
No.
one, sir.
No.
No one.
No necessary factor here.
No necessary.
No one.
There is no necessary factor.
I thought the necessary factor is the one with the highest percentage,
No.
which makes smoking.
No. A
No, it's not
necessary factor. Wait a minute. A necessary factor is a factor that must occur before the disease can happen. In this case, if you remove smoking, people that have genetic disposition and are exposed to asbestos and live in the city have cancer. Isn't it?
Yes, sir.
Now, somebody with genetic disposition and exposure to asbestos, even if he doesn't smoke and he live in the village, he can still have what? Lung cancer. Exactly. So in this case, there is no necessary factor. There are diseases that do not have a necessary factor in their pie. There are diseases that have a necessary factor, and some diseases doesn't have necessary factor. However, they have important factors. As she said, the one with the largest percentage is an important factor, smoking. Even if you have the genetic predisposition, you are not exposed to asbestos, and you don't smoke, you may likely end your life without cancer, isn't it?
Yes, sir.
Without lung cancer.
Yes, sir.
So these are sufficient causes. Out of these sufficient causes, none is a necessary cause. Now let's take the next disease, tuberculosis. Number one, exposure to the bacteria. Number two, weak immune system. Number three, lack of good health care. Number four, people that already have lung diseases. Now, which is the necessary factor in this case?
Exposure to the bacteria.
Exposure to bacteria.
Beautiful. If you are not exposed to the bacteria, even if you have weak immune system, you have lack of good healthcare system, you have lung diseases, you will not have what? Tuberculosis.
Tuberculosis.
Because you are not exposed to the
bacteria.
bacteria. Exactly. Now, this pie chart model can as well be taken back to triangle model. Why? Because it has an agent, isn't it?
Yes, sir.
Fine. It has an agent. It has a host, which is human being,
environment,
and then the environment, which is which could be congestion, lack of good housing. But then it's better you do tuberculosis in a pie chart, because there are so many factors, more than 3, so they cannot be represented in a triangle. Are you getting the argument?
Yes, sir. Yes, sir.
Once a disease have more factors, once a disease have more causative factors, then you transfer the disease model to
triangle,
to pie chart. If there are few factors, then you take it back to the triangle. Now, in this case of tuberculosis, exposure to bacteria is a necessary factor. Even if you don't have weak immune system and there are good healthcare system and you don't have any lung disease, exposure to the bacteria in itself is enough to cause tuberculosis, isn't it?
Yes, sir.
But then it need 1 or 2 of this to be sufficient to make it. Now, let's have highlight. An individual factor that contribute to cause disease shown in a pie chart in a piece of pie. After all the pieces of a pie fall into place, the pie is what? Complete, and the disease occur. The individual factors are called components.
Component
The
cause.
complete pie, which might be considered a causal pie, that is responsible for causing, is known as a sufficient cause. That is, you have enough sufficient causes going around. Now, out of those component causes, there are those that are called necessary factors. That is those that must be available before the disease will occur. Who is this God-blessed person that is touching the screen? A disease may have more than one sufficient cause, with each sufficient cause being composed of several component causes that may or may not overlap. For instance, when you saw that car accident, there are so many causes that you can form different components. You can form 4 or 5 different pie of how car accident occur without some of them overlapping. You can put drunk driving 2 or 3 times. That's drunk driving is overlapping, but you can as well remove drunk driving. A component that appears in every pie or pathway is called a necessary cause, because without it, diseases does not occur. If you look at the component for the HIV, you can have a pie having 3 causes, component: exposure to virus, indiscriminate sexual activities, lack of antiretrovirals. If you remove any of the 2, that is either lack of antiretrovirals or indiscriminate sexual activities, you change it with blood transfusion, sharing of syringes, you can still have HIV in as much as the necessary factor is there. That is exposure to the virus. Now, in summary, there are 2 models of disease causation: the epidemiology triangle and the causal pie. Epidemiology is not only about diseases, but it includes health-related events within human population. Health-related events, earthquakes, cyclones, and other dangerous environmental hazards are all part of what epidemiology is interested in. It's not only malaria. No, people are having fracture as a result of Okada riding, people being bitten by snake. Snake bite is also one of the neglected tropical diseases. Okay? If you are drawing a pie component for snake bite, what is a necessary factor there? Presence of snake, isn't it?
Yes.
You can see going into the bush, walking barefooted, going into bushy areas, going into swampy areas, whatever factor you can bring. If you didn't bring biting by a snake or presence of snake, then it's not sufficient, isn't it?
Yes, sir.
Fine. Now, the knowledge is very useful in addressing diseases.
Blessing.
This is, who is that calling blessing? Please mute yourself. Leave my daughter alone. This is, that is when you are not at ease. If you are not at ease or on ease when you join the 2, you have disease, isn't it?
Yes,
all those women that when they are invited for a function, they put shoes to match, blue shoe, green shoe, is too tight. When they are seated, they are not what? At ease. What is diseasing them is the shoe, isn't it? Yes, as soon as the function is over, they remove the shoe, put it in the bag, and put a flat shoe, and say, wow, what a relief. So they are diseasing themselves. So anything that will not make you at ease is what? Is diseasing you, so it's disease. So I want you now to take this as assignment. When you write the assignment, go back and post it in the chat room. Every one of you should go and take a particular disease, make it in form of triangle, take another disease, mention the causative agent, make a pie chart. Mention any disease and explain the causative factors and try to develop a pie for the disease. Also mention a disease and mention the environmental factors and agent responsible and draw the triangle. You go and post it in the chat room, and I want to see every person must have a particular disease triangle or a pie chart explaining where there is any necessary cause or there is no necessary cause. Thank you so much for listening. I don't know, we are not going to stay long because my battery is going low. I've just received a warning from the computer. So I will stop sharing my screen. I will make the slide available and then I will ask just 1 or 2 questions. If you have any question, go back and post it in the chat room. I will answer your questions. Okay, in the absence of anybody that raised his or her hand, I will call it a day. Is that okay with us?
Yes, sir. Good night.
Yes, sir.
Yes, sir.
Okay, fine.
Yes, sir.
When is
you,
the
sir.
deadline for the submission of your assignments?
Before next lecture.
Before next week, sir.
Before next class.
Which one is before next class? Give me a date.
Next class, sir.
12
Monday,
noon.
sir.
Before next class, sir.
Please, let's make it on that very day of the class, sir.
By 12
Now,
Sir,
you see,
suggest Monday.
you see, let me tell you how it
Thursday,
is
sir.
done. Let me tell you how it is done.
Yes, sir.
Today is Thursday.
Yes, sir.
You post it, all of you, by Sunday. Monday, Tuesday, Wednesday, we read it, we make comments.
I'll make it Monday.
But please, can we see the screen for the question again, sir?
The question will be posted on our
Okay.
platform.
Okay, on our chat. All right. Thank you, sir. I pray I don't miss your class again, sir. Thank you.
Thank you, sir.
It's like the
I hope I
host.
won't miss this class again, sir.
He has left. The host has muted himself.
Is there anybody in Meduguri Center here? Meduguri Study Center.
We are here.
Is there anybody from Meduguri Study Center?
Please, Akure Study Center.
Please, anybody in Meduguri Center, kindly chat me up.
Anybody from Katsina Study Center?
Yes.
Yes, we are here from Katsina.
Oh, thank God. I'm not alone.
Okay, so good everybody. Is there anybody from Gusau Study Center here?
Now we find a way to meet ourselves.
Please, anybody from Kano Center?
Anybody in Meduguri Study Center, please reach out to me. I
Who
just
is
dropped
the
my
new
phone number
host?
on the chat.
The new host should continue from where the professor stops.
Please, somebody should post the question here for us.
He said that he will be posting the question in our chat platform. So,
Please, anybody in Meduguri Study Center, kindly chat me up, please.
I screenshot it. Maybe I should forward it to the platform.
The new host should continue, please.
Who be the new host? Matami Okon.
Muhammad,
Please, if you screenshotted the question,
Okon, continue
for us.
Where is Okon?
You don't have to pronounce my name. It's Okoko.
Somebody can give a summary of
Now,
what
Okon we saw.
Don't forget, the recording is still on.
Please reach out to me if you are in Meduguri Study Center.
Is anyone from Local Jazz Study Center, Kogi State?
No.
Wow. So I'm just alone.
Don't worry.
All right, somebody must answer you.
Local Jazz.
All right, so good night, everyone.
All right, good night.
Good night. Good night. Good night.
Thank you.
But stay for your election.
Good night.
Bye.
Share the assignment, please.
I screenshot it. I'll forward it to the platform.
Thank you.
All right.
Okay, good day everybody. So I was trying to join the class earlier on, but couldn't. I guess it was because of network. So I joined where he was almost concluding on the epidemiology triangle. Okay, so what I learned from that was that the triangle is a description of how disease happen, how that there is a relationship between the causal agents, the hosts, and then the environment. Okay, yeah. So I don't know if there's anybody else that can make a contribution. But the last thing I would love to say about it is, which actually got my attention, was when he said that in order to bring an end to the disease, I think in one of the courses, one of the courses we are doing, is it terminating the disease or something? There's something about terminating disease, and I don't know who can remember that in social medicine.
Eradication.
Yes, disease eradication and what? And there were two. Is I think terminating the disease and eradicating it. There are like two terms like that in the course. Okay, not terminating. And there are about two. Well, okay,
It's
so he
elimination.
said that
Elimination.
yes, elimination, exactly,
Why English
exactly.
like that?
Elimination, it's elimination. Disease, yes, eradication and elimination. Who can differentiate the two for us here? The difference between disease elimination and disease eradication.
Eradication is complete removal from the population, complete removal. Then elimination is to control it, controlling it. Like we control measles, we control tetanus infection, and you control those ones. Like polio, you can eradicate it, like we eradicated in 2020.
Okay, thank you so much. In Nigeria, okay, thank you so much. So he was saying that the disease can be brought to end by distorting the relationship between the three, between the three, and then yes, between the three players. One of the things he said was that for some of the people those days in some of those tropical areas, how that they had to just leave the place. So in leaving the place, there's now a separation between the host and the environment and also the agents. And then even in terms of mosquito nets, how that when we give mosquito net, you are now creating a barrier between the agents and the host. So those are just the things I thought I should just share concerning what I learned. I don't know if there's anybody with anything before we can conclude the class.
Hello, class. Hello. Class.
Yes, you're audible. Yes, go ahead. Go ahead. We can hear you. We can hear you.
The one that has the elimination and eradication. No, it is cleared from a country. That's the two different elimination and eradication. I don't know if it is.
Sorry, you said?
I'm trying to differentiate between elimination and eradication.
Okay. Go ahead, please. I think according to the material, when a disease has been eradicated, it can still show up once in a while or so.
When they are able
Is that?
when they are able to destroy the disease in a worldwide.
Hello. Okay. You are saying something about the elimination and eradication. Okay, let me just also, in addition, talk about the causal pi model. In this case, like a pie chart. The sum of angle there is 360. So what I got from his explanation is how that here the causal agents are referred to as components or the exposures or whatever thing that is responsible for the disease. Okay, what even brought about this model is the idea that some certain diseases, that is the epidemiology triangle, does not sufficiently describe what happens for certain kinds of diseases, especially non diseases like cancer, and then some occurrences also, like we saw in the case of the accident. And so, because of the limitation of the epidemiology Okay, so I'm back. I guess there was the network, but I don't know if we still have some people here. Okay, we are on. Kindly give a signal or signify. Okay, so I guess this is me saying good night. Thank you.